right. I'm in my isolation room. It's just me and my computer and a book and water. Day 3 of my COVID isolation, not feeling too bad, like a cold, but not too serious. I'm going to show you a video today that's going to cover Monday and Tuesday. Monday, I know I won't be in. I might be cleared by Tuesday, working with a school nurse. I don't know. But if I'm not in person Tuesday, then this video will also contain Tuesday's lesson. So I'll post this, well, it's posted for Monday and Tuesday. So here we go. And right here. That says Tuesday. Let's go to Monday. So Monday is right now. We're going to discuss the difference of squares. That's what DOS is, difference of squares worksheet. It was a CUDA worksheet, which is this worksheet right here, right? Not in the worksheet packet. It's not in the stapled packet that I gave you. I know I'm confusing you with this stapled worksheet packet and then this one, and then I posted another one for tomorrow. So it's a lot of stuff. But anyway, let's go through that. You saw the video where the man taught you how to do this. I'll discuss that, make sure you know it. And then your homework for Tuesday is this. This is in your regular worksheet packet, the one that we handed out in class. It's all stapled, page 110. So here we go. Let's go through this difference of squares first. All right, so here's what we learn about difference of two squares. It's a binomial. Binomial means one term, two terms rather, one term, two term. The terms are separated by a minus, or it could be a plus 2. This is also a binomial, one term, two term. We're interested in a binomial that is a difference. Difference means going to be a minus. Difference. The one I had here a second ago is not a difference. So we don't care about that. Going to be a difference. And then the two squares. These numbers have to be what's called perfect squares. Well, what's a perfect square? 1 times 1 is 1. So 1's a perfect square. 2 times 2 is 4. 3 times 3 is 9. 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, and so on. Those are all perfect squares because they are a number times itself. So here's the deal. Going to have a minus. These both have to be on our perfect square list, which they are. And then any exponent has to be even. Doesn't have to be a 2. Could be a 4 or a 6 or an 8. Going to be even. So those 3 things have to be evident in order to factor by difference of squares. And in all these problems, I believe that is evident. So the way you did number 1 is, okay, it's a minus. 49 is a perfect square, so is 25. Exponent even. So 2 sets of parentheses. Always 1 plus, 1 minus. Then how do you get 49? 7 times 7. How do you get b squared? B times b. How do you get 25? 5 times 5. And that's it. That, my friends, is it. I don't know why this widget page pops up, but I can see it's 50 degrees out there. What else? Oh, the Bruins won 4-2. That's good. All right. Will that go away on its own? I don't know. I hope so. I'm afraid to touch anything. I'll go down the rabbit hole. Okay, it's gone. Let's look at number 3. Does it qualify? Well, it's a minus. Yep. 121's a perfect square, so is 25, and that exponent is an even number. So yes, it does. Always 1 plus and 1 minus. 121's 11 times 11. N squared is n times n. And 25 is again 5 times 5. Looks like number 5 is already done here. We'll do it. We'll do it again. One plus, 1 minus. 169 is 13 times 13. 13n, 13n. And 9 times 9 is 81. Okay, and so on. Number 6 is 9k plus 13, 9k minus 13. Number 13, p plus 8, p minus 8. 14, 7n plus 1, 7n minus 1. How about 15? 1 plus minus 6, 6, and n, 11, 11. So I think we get the idea. So let me throw you a little curveball here. What if we had this one? What if we had this one? That's okay. What if we had this one? And what if we had this one? Okay. Let's see. Let's see if they qualify as different to squares. Well, right away, that's not a difference. I know 9 is a perfect square. I know 25 is a perfect square. I know that's even, but it's a plus, so no good. Cannot be factored. Let's go to this one. Minus, that's good. 25 perfect square, yes. 49 perfect square, yes. We get two variables, a and y, but they both have even exponents, so it's a yes. Plus, minus, 25 is 5 times 5. A squared is 8 times a. In the back slots, 7 times 7, but now we need a y and a y. Okay, no problem. How about this one? Got a minus. 4 is a perfect square, so it's 81, and the exponent's even. It's 8 this time, it's okay. 4 is 2 times 2. Now x to the 8th. That's going to be x to the 4th times x to the 4th. Because when I multiply x4, I add exponents to get x8, and then 9, 9. All right, so we're looking good. But how about this one? 2x squared minus 18. Nope, 2 is not a perfect square, neither is 18. But before we say cannot do it, we can take out a GCF of 2. Remember GCF? We left with this. Take out a 2. 2 divided by 2 is 1. X squared. 18 divided by 2 is 9. And then this is a difference of squares. X plus 3, x minus 3. So I want to make sure you can do ones like those. So let's try these ones, kids. It's that one. And how about this one? Try each of those, and the key is GCF first. So the GCF here is a 5, x squared minus 9. We just saw a minute ago, that's x plus 3, x minus 3. Oh, I'm not very creative. Same thing here. Here we can take out a 3 and also an a, 3a. We left it a squared minus 9. Again, a plus 3, a minus 3. How about one more? How about give me a sec here, 24. How about that one? Doesn't look like a difference of squares at all. But if we do our GCF, we can take out a 6. We can take out x to the 1, can take out y to the 1. Divide, we get 1. You know, 5x we took out once, there's 4 left. There's 1y, I took it out, it's gone. Negative 24 divided by 6 is negative 4. 1x, I took it away. 1y, I took it away. So that's that. That's GCF, which we did back in my pre-COVID days. Now, is this a difference of squares? Yep, one's a perfect square. Oh, that's not 24, you idiot. It's 4. Here we go. You say, how did you get that? 24 divided by 6 is 4. So now we're good. 1 plus, 1 minus. How do you get x to the 4th? X squared, and 4 is 2 and 2. So that's your complete answer. That's like, this is your complete answer. The GCF is part of your answer. Okay, so that's that topic. Here's our new topic. Our new topic is factoring trinomials. Looks like I've already got it here. And the reason is because I already did this video once. When I went to record it, it didn't record, which is not good news. All right, so trinomial. Trinomial is 3 terms. A squared minus 7a plus 6. 5x to the 3rd plus 7x squared minus 10. Those are examples of trinomials. The pluses and minuses to separate it into 1, 2, 3 terms. All right, so we're interested in trinomial like this. While you write that down, I'll see who's texting me. Okay. All right, well, we said factoring is the reverse of multiplying. Let's look at a FOIL problem. X plus 2, x plus 3, FOIL or double distributive. If you had this, you'd Do that. X times x, x squared, x times 3, 3x. Then 2 times x, 2x. 2 times 3 is 6. Collect the like terms, x squared plus 5x plus 6, which is exactly what we have here. So we can start with a multiply and get a trinomial. We can start with a trinomial and work it, factor it into this. This is how it works. We look at this last number, the constant, and we say we need two numbers that multiply to 6. Then we look at this number, the coefficient of x, we say we need two numbers to add to 5. So give me two numbers that multiply to 6 and add to 5. Well, what numbers multiply to 6? 1 times 6, or 2 times 3. Which of those adds to 5? 2 and 3. So it's x plus 2 and x plus 3. Yeah, right there. So you see, FOIL for trinomial, trinomial, back to FOIL. So these are not difficult. Let's try that one. So your last number, your constant, is your multiplier. So multiply to 32, and your coefficient of y is your adder. So add to 12. Now what multiplies to 32? I always start with 1. 1 times 32, then I go to 2. 2 times 16. 3 doesn't go in at 32. 4 does. 4 times 8, and that's it. Do any of these add to 12? Yep, the 4 and the 8. 2 parentheses. It's a positive 4 and a positive 8. Y squared is y times y. That's your answer. Widget, that's your answer. All right, how about this one? Oh boy, I can't do it because that's in the way. You have to tell me in class how to stop my computer from widgeting. Okay, how about p squared plus 24. How about this one? Here's our multiplier. Multiply to 24, add to 25. Okay, I always start with 1. 1 times 24, 2 times 12, 3 times 8, 4 times 6. Well, that's what adds to 25. So it's p plus 1, p plus 24. Okay. How about ones like this? Only difference this time is we have a minus there. So we multiply to 15, but we add to negative 8. Well, let's think about this. What kind of numbers multiply to a positive, but add to a negative? We have three choices: positive times positive, negative times negative, or one of each. Well, a positive times a positive multiplies to a positive, but if I add two positives, I'm not going to get negative, so it can't be that. A positive times a negative here, positive times a negative is negative, so it can't be that. This here is supposed to say plus 15. How about a negative times a negative? A negative times a negative is a positive, and we add two negatives, we get a negative. So it's got to be negative, negative. So when I make my list, -1, -15, -3, -5. Don't try 3, -5, because those multiply to a -15. So here it's -3, -5. All right, you try this one, please. 9. Multiplies to positive 9, adds to -6. Again, it's going to be a negative times a negative, right? Is it -1, -9, or -3, -3? It's that, m minus 3, m minus 3. All right, how about one like this? Let's try that one. Here we multiply to -24, add to positive 5. Now to multiply to a negative, I need a positive negative, don't I? The only way two numbers can multiply to a negative is 1 plus 1 minus. So when I go through my list, I'll start +1, -24, -1, +24. Why do I have to list them both? Because these two add to -23, and these two add to +23, quite different. Let's go to 2, +2, -12, -2, +12, +3, -8, -3, +8, positive 4, negative 6, negative 4, positive 6. Which of these adds to positive 5? There it is. X minus 3, x plus 8. All right, one more for you to do. Uh, 20A, try that. All right, multiplies to a negative again and adds to a negative. Well, to multiply to a negative, you need a plus and a minus. So plus 1, negative 36, negative 1, positive 36, 2, negative 18, negative 2, 18. Uh-oh. 3, negative 12, negative 3, 12, 4, negative 9, negative 4, 9, and 6, negative 6. Do any of these add up to negative 20? No, they don't. So this one could be cannot be factored. I didn't mean for that to happen, but it's good to see that too, cannot be factored. What I think I meant was for this to be like a 16. If that was negative 16a, then it would have been this combo. Okay, so that's your homework on page 110, I believe. Whoops. No. Nope. Page 110, 1 through 18. Let's look at page 110. Page 110, 1 through 18, and you look at these, they're just like what you just did. Exactly. Trinomials. Well, that's it, exactly. All right. Also, Tuesday's homework. Where is it? Where is it? Where is it? There it is. Tuesday's homework. We're going to do more practice on 3 types of factoring you learned so far. Difference of squares. No, GCF, difference of squares, and this is a trinomial. So there's no new topic, kids. What I want you to do is a worksheet 1 through 30, 41 through 50 odd, make that ODD. It's a worksheet posted on the GC, 1 through 30 odd and 41 through 50 odd. Let me see if I can pull that up for you. No, it's not there. All right, let me share the screen here. Okay, this was from your Google Classroom. It says factoring packet. So it's this factoring packet, looks like this. And when I say 1 through 30 odd, scroll up, there they are. And they're all, it even tells you how to do them. These are all GCF. 1 through 10 are all GCF. These are all difference of squares. They call it dots, difference of 2 squares. Those are all difference of squares. Then these are GCF and difference of squares. Like we practiced today, take out a GCF first, and then do difference of squares. And then you skip these and go 41 to 50. That's the trinomials. All right, so this lesson, this video takes care of Monday and Tuesday. So Tuesday, there's not an additional video. Tuesday, it's you doing this worksheet stuff as more practice. Okay, kids? Very good. I'll see you soon. Bye-bye.